In this video, let's move right on to the next get endpoint, which is the one to retrieve a single bank. So once we're done, when we make this request in Postman here to API/bank/some account number, we want to retrieve, or we expect to get that bank back from our API. So let's go ahead and do this. Of course, we're going to start off at the test. And I don't want to bore you with going bottom up for all of these endpoints. You've seen it now once with test-driven development, how you build the system up, how you test each layer using unit tests. But for this one, now for the following videos, I will just create the controllers integration tests. But feel free to keep also writing the unit tests just for practicing Kotlin as well as JUnit 5. It's a really good practice. Now what I'm going to do here is I'm going to create another test case saying should return the bank with the given account number, let's say. And then let's say given the account number 1234. When our mock-MVC request performs a get to our API/banks /account number, and we'll again do a print. And so with my live template, it automatically jumps to the next one, but I'm gonna combine these two into a when then block again here. And also I want to expect that I get a status code of 200, so it should be okay. And I'm going to keep it at just this simple test case for now. Again, still doing test-driven development, even though I will only be writing the integration tests from now on. And now I actually started the application because that's the last thing I ran, but I want to run the test class. All right. Obviously this will fail, so let's go to our bank controller, and here we'll need another get mapping, and I'm going to call this method just bank. And now there's actually something new coming in, because this one has a parameter which is the account number, and that test case takes really long for the first time but it's faster afterwards. So we have the failing test. Let's see what happens, and of course we get a 404 because there's no such endpoint. And so this account number is a string, but in fact what we want to have is this should be a path variable which tells Spring that it should get this variable or the value for it from the request path. And so a path variable is a variable that's inside here. Now what we want to do is based on our base path of API/banks, this get mapping is actually on a ID subpath. And in fact, I have to call this one account number because it has to match the name of the parameter here. And this way, Spring Boot now knows that it's a get mapping on API/banks/some account number. So this way we have it available in our function body. And of course, we just want to call the service.getBank and pass on the account number. And as you might notice, I'm going a bit too far already. So for this test case we have right now, we can also, let's say, just return you want data about the account number. And this way we can even test that it's parsing the account number as it should. And then rerun the tests. Yep, indeed, that's enough. And we can also check here, we have a response body of you want data about 1234. So perfect, Spring Boot is looking at the account number and giving it to us in our method. So now let's be a bit more comprehensive here in the test. So we want to expect that our content type again is application JSON. And in fact, I should move this into one block here using this Kotlin DSL. So I want to expect all of these and don't need this bracket. So expect all of these. And then again, I'm using JSON path. And in here now we only have a single object. So we don't need any array access here. Instead, we just use the root object again. And on this one, we can check, for instance, that the trust should have a value of, let's see, in the mock data source, a trust of 3.14 and a transaction fee of 17. So let's go ahead and say the trust should be 3.14 and also the transaction fee should have a value of 17. And then I'll run this test again, which will now obviously fail. So in the bank controller, let's just move on. So here we're going to call our service and we want to get the bank with the given account number. Now, right now we don't have this method yet. So let's create this member function, and it's going to take an account number of type string and it should return a bank. So this one should also be on the bank controller. Then it could have already inferred this type. And so then in here, we're gonna again just delegate to our data source and retrieve the bank with this account number. Now later on, there might be more logic in this service, but for now, we're just gonna delegate to our data source and again, create this member function, which also takes the account number and returns a bank. And that's all I want for this interface. So now let's go into our implementation. That's not the implementation I wanted to go through. Go to this one's implementation. So mock data source. And in here, we can now implement the remaining interface methods that we do not yet have implemented. So retrieve bank, and in here we want to say return from the banks, the first one, which matches the following query. Its account number should be equal to the given account number. And let's see what happens if it cannot find this one. It would throw a no such element exception. And this is just fine. That's actually quite nice. That's probably what I would have thrown otherwise. Let me also refactor this, convert it to an expression body. And then for now, that's good. We're going to take a look at what to do if we have this no such element exception later on and how we can map it to the correct status code. For now, we have all the layers. So let's see what happens if we run our test again. And it's already working just fine. So let's see, in our response, we indeed get our bank object. So that's looking really good, but we're only testing the happy path right now. And that's not really a good practice. I also want to test what happens if I give it a non-existing account number. And now to do this, I actually want to restructure this a little bit because it can become quite confusing if you have lots of tests and they're all just on the same level here. And that's why in JUnit 5, there's something called a nested class. So here again, I have a live template for this that I'm going to show you in a second. But basically, you have this nested annotation, which tells JUnit to look at all the test cases in this class. I'm also going to use this test instance per class, which means that JUnit is not supposed to create a new instance of this class for every test case that it runs. And what's also really nice is this display name. So this one here, I'm just going to call getBanks, because what I want to do with this nested class is I want to encapsulate all the tests for this endpoint or for this method. And I'm just going to call this class getBanks as well. And in here, I'm going to move this test case. That's the only one we have for this endpoint. And then it's nicely nested in its own little scope. And let me just do the same for this one down here before I show you what exactly happens and what the live template looks like. So I'm going to call this one getBank with a singular. Of course, introduce this import. That makes it a bit easier. Apparently, it cannot show the context actions while it still wants me to add something here. So let's get this done, and then let's import this one. And I'm going to move the test case in our nested class. And then this one also has its own nice little scope. All right, so with that done, let's run the tests again and let's see what happens. And we see that we see nothing. if this happens, so what we expect is that the display name getBanks would be shown here instead of this more cryptic qualified class name. However, what you have to do to make this work in IntelliJ is go to the settings, and then in Gradle or under the build, execution and deployment, you have to run the tests using IntelliJ IDEA. And I think even you have to also build the project using IntelliJ. You can try without, but for now, to be sure, I'm going to do it like this. And then if I run them again, it should work. Unfortunately, at the moment, if you run your tests using Gradle, it basically doesn't expose this information to the IDE. So for some reason, it's still running the tests with Gradle. You can see it even says open the Gradle test report. So I think what I'll have to do is just restart the IDE and maybe even invalidate the caches. You might face the same problem, so I'm going to show it here. So restart, and it will tell you can also invalidate the caches and restart, or just restart. To make sure, let's try invalidate and restart, and then let's see if we can get it to work. So if you chose invalidate, of course, it's going to take some time now to index everything again and rebuild the cache, but hopefully that will get it to work. It's a bit unfortunate that there are sometimes a few hoops we have to jump through, but it's just a tooling issue. And also, I think even if you don't care about the display name, the nested classes are just a separate feature. So you can also use them obviously without a display name, and they still give you a nice scope for your tests. You can also use them for defining the test prerequisites. So here I'm using them each for a different endpoint or a different method here. But what you can also do if you have different, for instance, state-based tests, is you can have nested classes that build up your test prerequisites. So something like given a valid request and then given an invalid request and so on. This way you really know where you're currently at when you're looking at a test case, because you can just look at the classes that it's nested into. Another advantage of this kind of nesting is if you look at the outline view in your IDE, it gives you this really nice way to browse through your test cases and see what's already being tested, get an overview, which can be otherwise really hard if you have a long test class, which can happen quite easily. So much for why the nested classes are a really nice feature, I think. If you want to do the same in terms of live templates, again, just go to your live templates, and then under Kotlin, you can add a new one. And this nested one looks like this over here. So yeah, basically you saw it. You have these kind of placeholders for the display name, the class name, and then the body. And this one should be applicable in a class realm because you're creating an inner class, an object declaration maybe, and then also other. So really, well, you don't want it in comments, but just make sure it's class. That's the one where you're actually going to use it in. You can probably skip the other two, but it doesn't really hurt either. All right, so now without further ado, let's just hope that it works now. Running with and also building with IntelliJ. All right, finally. Yeah, so sometimes you have to restart IntelliJ or even invalidate the caches, but now it's running the tests not using Gradle, and you can see the display names here. Of course, you can also have spaces in between, just like with the test names. And actually, I just noticed I haven't really talked about this yet, but in Kotlin, you can use backticks in your method names and then have these kinds of names with spaces, for instance. Obviously, this is really nice for test cases, but please don't use this in your production code. It's not a good function name in general, but it's really great for writing tests. All right, so here we are, we have our running tests, and we have the tests that we have so far nested into their specific scopes. Now what I wanted to do is add another test case here saying that it should return not found if the account number does not exist. So given an account number of, let's say, does not exist, so it's always nice to make your test data very readable. Then I want to have again this combined when then block. So when I say mock-mvc.get API banks account number, and I should extract this to a variable because I'm using it 3 times already now. So this will be a, let's say, base URL. And obviously I don't want it just here, I want it at the very top because it's also relevant for all the nested classes. And then here I can just say when I get the base URL, and over here when I request base URL / account number, and the same here. Then first of all, I'm again gonna print out what's happening, and I expect that the status code in this case is not found. And to make this error test case stand out a bit more, I'm actually gonna write this in uppercase. So let's run it again and see what happens. All right, here we are. We have a failing test again. I think it's actually also useful to select here the first test that failed when all the tests have run. Then it would already mark this one. So let's see what's happening down here. Collection contains no element matching the predicate. That's what we expect. However, it just says request processing failed. So it's really just throwing an exception and just completely failing instead of giving a proper response with a proper not found status code. So now we get to another interesting topic in Spring Boot, which is error handling. So for this one, there are multiple ways to solve it. For this tutorial series, I'm going to use a very easy one. So in our bank controller, what you can do is you can also define an exception handler. And what we really want to do here is in our controller, we want to map any internal exceptions that may have occurred, like the no such element exception. We want to map those to the appropriate status codes. And so Spring Boot has this really nice capability where you just say you have an exception handler for some type of internal exception that's not really or shouldn't be exposed to the outside. And here we looked it up, it was the no such element exception, the one actually coming from Kotlin, not from JavaUtil. And then here again, this will be an annotation on a method, and I'm going to call this handle not found because you can give it any name you want, but this of course should signify also what you're trying to do. And then it gets a parameter, which should be the same type as the exception that you're handling. So here I'm going to pass in this no such element exception. So Spring Boot will be responsible for basically catching that exception and providing it to this method. And it's going to return a response entity. So really just a response, a proper response with our 404 response code. And here I'm going to create a simple response entity using the exceptions message and the status code not found. So with just 3 lines of code, we've achieved that Spring Boot will handle any no such element exception that bubbles its way up into the controller. It's going to provide it to our handle not found method, and we're going to respond with this response entity that we have. So let's go ahead and run the tests again and see if it's already working as we expect it to. All right, perfect. So now in this test case here, when Spring Boot encounters the account number that doesn't exist, it would go into our mock bank data source, and the first method here will throw a no such element exception, which is going to bubble up into our data source, which is again going to bubble up into our service. And then finally, it's going to bubble up to our bank controller. And here we have this exception handler. So like I said, there are different ways to do this in Spring Boot. If you have many controllers, you don't really want to define this in each and every controller. So there's also a way to do it for your entire Spring Boot application. But again, for these tutorials, this is just fine. And in fact, you can also look it up here in the output. So the response now has error code 404. And even you get the really nice response body, collection contains no element matching the predicate. Of course, you could also extract this away a bit or abstract it to no such bank was found. In fact, let's go ahead and just do this so you know how to. So in our mock bank data source, instead of just calling first, we can also say first or null. But then if it is indeed null, what we're going to do is we're going to throw our own no such element exception. And now we can define our own message. So to give a more useful answer in our response, we can say could not find a bank with account number and then pass the account number. And then this way, if we run the tests again, we're not really checking the response body, but we could. For now, let's just look it up in the logs here. So for this test case, could not find a bank with the account number does not exist. And obviously this is a more useful response for your users because it's more related to your domain with the banks, with the account number, and not just a super generic error message. All right, really nice. So now all that's left is to jump back into Postman and just see if it also works here. So really, we already have our automated tests, but it's always nice to see it manually as well. Of course, I should also start the application first if I want to do this. And once we have that, then I can go to Postman and let's see what happens. All right, so I get my bank with account number 1234. Also, if I try something that doesn't exist here, I will get could not find a bank with this account number. All right, perfect. So everything working as expected. So in this video, you really learned quite a few new things, starting with the get mapping that actually provides a path variable. Then of course also using the mock MVC to test the non-happy path, which also led us to explore some of the exception handling capabilities of Spring Boot. And obviously just how to create a new endpoint, this time top down, going through the service, then going through the data source, and then also implementing that one. So I hope you've learned something in this video. If you did, please leave a like, check out the links in the description, and also let us know in the comments what other topics you might be interested in the future. And then I'll see you again in the next video.